All right. Hey guys, so today we're going to look at solving systems of equations through substitution. So before we looked at how to solve them with a graph, and so today we're going to look at how to solve them if we don't have a graph. But let's look at these first couple. So I want you to determine if each of the systems could be represented by the systems down below. So looking, we've got 3 here. Okay, there's 4. So looking at this, we've got this first system, x plus 2y equals 8 and x equals -5. So could this be this graph? So what would we look at if we wanted to know if an equation matched a graph? Well, we would look at the slope and the x or y intercepts. Okay, so looking at those, we can tell. So on the graph, we know that it's going to have a positive y-intercept for the black line, and the slope is going down, so we know that it has a negative slope. Okay. And then we have a blue line that's vertical, so this line is going to be x equals some number, and we know that right off the bat. So here, we look at this first equation, x plus 2y equals 8. Well, in that equation, I can't see the slope or the y-intercept, so you have to solve and put it in slope-intercept form to see that. But let's look at the second one, x equals -5. Well, we know that this equation has to be x equals something, but it's in the positive side. So -5 would be over here. So we automatically know that this system is not matching that graph. All right, looking at the next one, we have y equals -7x plus 13. Okay, well, this point could be 13. That's the y-intercept, and the slope is -7. So this could be 13 and going down 7 because we don't know what the scale is. But this one, y equals -1, would be a horizontal line at -1. And so it would be below the x-axis here, and we do not have a line like that on the graph, so it's not the second step. For this one, if we solve this one for x here, we would have x equals 8/3. Okay, well, x equals 8/3. Well, this could be 8/3. We don't have a scale, so it's very possible. Let's look at the next one. To put this in slope-intercept form, we need to move the x term to the other side. So we would have y equals -3x plus 15. This could be 15, and it could be going down by a slope of -3. So this is a definite possibility of what that graph is representing. If you look at the next one, we've got one left here. Well, this has a y-intercept of -7, and -7 can't be above 0. It would be down here. And it has a positive slope of 2, so that line would be going up, not down. So it could also not be that last one. All right, so today we're going to learn how to solve these systems of equations without looking at a graph. So sometimes we don't have a graph, or we don't have access to graphing technology, and sometimes it's just faster not to graph them. So our steps that we're going to follow today are, step 1, we have to solve one equation for a single variable, which means you either need to isolate x or you need to isolate y. So once we have those by themselves, we can do step 2. We're going to substitute the answer into the other equation. You can't plug it into the same one. You have to plug it into the other equation and solve for that other variable. Then step 3, we're going to write our answer as an ordered pair. And step 4, we're going to check our answer by putting x and y both back into the equation to see if it makes it true. Okay, so go ahead and pause the video and take notes. You're going to want to keep up with this information here. All right, so we've got this first equation, A, so we have to follow our steps. So step 1, we need to solve for a single variable. Well, if we're looking at our system, we already have x equals -5, so it is already by itself. So we're going to go ahead and go on to step 2. There we go. So step 2, we're going to plug in that -5 in place of x into the other equation. So I need to know that I'm using the other equation, so let's go ahead and write it down. X plus 2y equals 8. So everywhere I have an x, I'm going to replace that with -5. Okay, so I'm going to have -5, and I want you to get in the habit of when you replace a variable, put parentheses around it. And this will make sense in a minute. I'll show you a reason why we want to do that. Okay, so finish out the equation, 2y equals 8. So from here, I'm just going to use my order of operations and inverse functions and solve for y. So I have a -y. I need to combine it with its like term 8. So I'm going to add 5 to both sides. Okay. Those cancel out for me. I bring down my 2y. And 8 plus 5 is 13. Then I have 2 times y equals 13. So I undo multiplication by dividing both sides by 2. 2 divided by 2 cancel out. I'm just left with y. And 13 divided by 2 is 6.5. So my y is 6.5. All right, step 3, we're going to write our answer as an ordered pair. Okay, so we have our x, we have our y. So we just write -5, comma, 6.5. And so we have our solution. Your solution to a system is always going to be an ordered pair. And then for step 4, we have to plug that in. I don't know if you can see that green very well. Let's go orange. Let's try this orange. So in both equations, if I have x is -5, well, if I put -5 equals -5, that's obviously going to be true. So let's plug it into the other one. X plus 2y equals 8. So instead of x, I'm going to put -5. And instead of 2y, I'm going to have 2 and then 6.5. So what does that look like without parentheses? It looks like I have 26.5, but that's not really what I mean. I have to multiply whatever y is by 2. So this is why it's important to replace a variable with parentheses and put the number in there so we know we're multiplying 2 times 6.5 and not having 26.5. Okay? And then just continue to use your order of operations to see if it's true. So -5 and then 2 times 6.5 is 13. And -5 plus 13 is 8. So our solution, a -5 and 6.5, is a true statement. So that is our solution. Okay. So let's try another one. I want to see if you can set it up by yourself. All right. So try to do this one on your own. Okay. All right. So we start with step 1. Step 1 is to get a variable by itself. Well, if we're looking at our system, y equals -1 already has y isolated for us. So then we can just move on to step 2. And step 2 is to plug it into the other equation. So I have my other equation, y equals -7x plus 13. All right, and so where I have y, I'm going to replace that with -1. And then we can just solve for x. So I would subtract 13 from both sides. And then bring down the 7x. So that gives us -14 equals -7x. Divide both sides by -7. And so -14 divided by -7 is 2. And 1x, or just x. So now I know that x equals 2. And step 3 is to write our answer as an ordered pair. So we have y is -1 and x is 2. So we have 2, comma, -1. Because in ordered pair, your x value always comes first and then your y value. All right. And so let's check that to make sure that it works. So step 4. Well, if I put -1 in for y, -1 is equal to -1, so that works. So let's put it into the other one. So we would have -1 equals -7 times 2 plus 13. -7 times 2 is -14 plus 13. So -1 is equal to -1. So it checks out for us. All right, go ahead and try C. So step 1 here is a little different. See if you can figure out step 1. All right, step 1, we have to isolate a variable. So we have 3x plus 8. Not 3x plus 8, 3x minus 8. Oops, there's the whole thing. Try that again. 3x equals 8. There we go. So I need to get x by itself. So I'm going to divide both sides by 3. So x equals 8/3. All right. Step 2, we're now going to plug that into the other equation. We're going to leave it as a fraction because 8/3 is a repeating decimal, and if we round that, it's going to make the rest of our answer wrong when we get to the end. So our other equation is 3x plus y equals 15. Okay. And wherever I have an x, I'm going to put an 8/3. So here's another situation where if I just write 8/3 instead of putting parentheses, it looks like I have 3 and 8/3. And that's not what I have. I have 3 times 8/3 plus y equals 15. Okay. So now I can continue to use my order of operations and solve for that. So 3 times 8/3 cancels that out, and I'm just left with 8 plus y equals 15. Subtract 8 from both sides. Bring down your y. 8 minus 8 cancel out, and 15 minus 8 is 7. So now I know that x is 8/3, y is 7. I can write my ordered pair for step 3. So we have 8/3, comma, 7. Let's plug that in and see if it works. So if I have the first equation, 3 times 8/3 equals 8. Well, 3 times 8/3 is 8. And so that checks out. And if I plug it into the other one, I have 3 times 8/3 plus 7 equals 15. Okay, well, this is 8 plus 7. And 8 plus 7 is 15. So that checks out for us. All right. Hopefully y'all got those right. Let's try. We got one more here. Okay. Go ahead and which equation do you want to solve for here? We can kind of go 2 different routes. And so I'll show you both methods. For step 1, let me change color. So for step 1 here, I'm going to get this one by itself. So it doesn't really matter. In the top equation, we already have 2x minus 7 set equal to y. So y is already solved for, but it might be scaring you a little bit that we don't just have a number here. We have an expression. In this one, there is no x. The top equation has both x and y. And so you could solve for either one. So I'll show you both ways. So here's the first way. If we leave it the way it is, we already have y solved for. Okay. And so we can go ahead and go to step 2 and plug that in. So I'm going to be replacing this entire 2x minus 7 with the y. So I have 4 plus y equals 12. So I'm going to have 4 plus 2x minus 7 equals 12. Okay, so I've just taken what y is equal to and put it in place of the y in the other equation. So now I'm just going to combine like terms and see what I get. So here, this is all addition, so I can ignore the parentheses. Nothing is being multiplied here. So I do have some like terms, 4 and a -7. So 4 minus 7 is -3. So I'll have 2x minus 3 equals 12. Then I need to add 3 to both sides. So I have 2x equals 15. Divide both sides by 2. And x equals 7.5. Okay, so I have an x now, but I still have to find y. So I'm going to take that and plug it back in to the other equation. So we kind of have 2 steps here. We have to repeat that step 2. Okay, so repeat step 2 again. So step 2B. Okay. So we have, we just plugged it into 4 plus y equals 12. So we have to plug it into the other equation. Y equals 2x minus 7. So we'll have y equals 2 times 7.5 minus 7. All right, so 2 times 7.5 is 15. Ooh. 5, that's a 5. Minus 7, and 15 minus 7 is 8. So we can get it that way, and we get our answer. Step 3. We have 7.5, 8 for this answer. All right, so that's the first way you could have done it. I'm just going to erase this and show you the second way that we could have done this. So we could have started by using the second equation instead of the first. So for our step 1, we would have had 4 plus y equals 12 and subtract 4 from both sides. And we know that y is equal to 8. So you can get it that way. And then moving on to step 2, we would plug that into the other equation. Okay, so we have y equals 2x minus 7. So where I have a y, I'm going to replace that with 8. So I have a equals okay. So if I add 7 to both sides, bring down the 2x, and then divide by 2, I get 7.5 equals x. And so either way, I get the right answer. So my step 3 here is still going to be the same. Okay, so this way was a little quicker because we used the equation that only had one variable. So if you have equations that have 2 variables, then you're going to have to repeat that step 2 by plugging in your answer to the other equation again. So if you can pick which equation is faster to solve for, it'll help you in the long run because we had one less step with this process. All right. So I want you to try to do this one on your own. This is your cool down. So see if you can figure out how to do this one. It's a little bit more tricky because it does have both variables, but I think you can do it. Good luck, and I'll see you on Wednesday in a video. Tomorrow you have practice problems.